Hey everyone, welcome to the next lecture, which is going to be about diodes. So in this lecture, we want to cover three things. What does it mean to forward bias a diode? What does it mean to reverse bias? And why do these things happen? What things? Well, let me tell you. If I have a diode, and we learned in the last lecture that it would have an N and a P side, forward biasing would mean that I hook it up like this. Keep in mind, this is a battery. We could also draw it like this. And the long side would be the anode. So the positive side, and the small side would be the negative. With a diode, again, the P side would be a positive, or we would call it the anode, and the N side would be a minus, or the cathode. A way to keep these straight, if you ever confuse anode and cathode, is anode is positive, and I always think of it like A, like if you get an A plus in a class, that's really positive. On the other hand, with a cathode, if you were to get a C minus in the class, well, you might be a little more negative. Or maybe you don't care, and that's okay too. There's more important things in life than grades. But generally, an A plus is going to be positive, and a C minus is going to be more negative for most people. So in this particular setup, what happens is it causes the current to flow. So, there's more positive charge connected over here and more negative charge over here. So the current flows pretty much like normal. It causes, there's a minimal amount of energy needed to overcome the junction. And depending on the design of it, it's going to be a different amount of voltage. But if that's enough, it'll be overcome and current will flow like normal. However, if we hook it up in reverse, if I have my N and P side and I flip it, so now I have my positive connected to negative and my negative part of my battery connected to the P part of the cathode. Now what happens is these negative charges are attracted this way and the positive charges are attracted this way. And what that does is it causes the depletion region to expand. And this stops current flow, which is a very interesting thing, and we're going to play around with this a lot more. So basically, this ends up working like a check valve. With a check valve, if water flows down a pipe, it can push the valve open and keep flowing. But if it flows the other way, it's going to push it closed again and stop the flow. So it basically works like a one-way valve. So in the forward biasing, where positive connects to P and negative connects to N, it causes current to flow as the voltage is applied. But in reverse biasing, when you flip the poles, nothing will happen until, if the voltage gets extreme enough, it can overpower this, and that will basically burn up the diode and it will no longer be functional. So it is possible to overcome that depletion zone. It just takes a lot of voltage and it basically breaks your diode. So what we end up, if we put this in a circuit, we would have a diagram like this. And I'm going to do it like this. And we have a symbol for a diode that's a triangle with a line, and the triangle points, so that's the P side, and the line does not point, so that's the N side. So in this setup, current will flow through this diode. If we reverse it, the current will not flow. So in this bottom one, and this is a little bit hard to see, so I'm going to scroll down and redraw it. So if I reverse bias it, there is no current flow. So this is really important. So because of this, we say that diodes have polarity. They have a cathode and an anode, and they can control, but basically stop current from going in a direction we don't want it to go, which is also super useful. So that is what a diode is. It's basically just an application of our p-n junction, and it's something that we start to see all over electronics. So we're going to talk about some different applications of diodes to wrap this unit up, and then we'll move on to other things that we can make out of semiconductors using these N and P materials.